space history. Voyager 1 is now a starship.
These were these craft built and launched in the 70s that have now kind of gone past what we call the heliopause, the heat bubble of our sun. They're kind of going into interstellar space. And what they detected a few times is they detected these bulks or waves of plasma.
Voyager 1 has been traveling through the cosmos for nearly half a century, a lonely spacecraft carrying humanity's ambition into the vast unknown. It was launched in 1977, at a time when the solar system seemed enormous and unreachable, yet now it drifts beyond the protective bubble of the sun's influence in a region known as interstellar space. For decades, scientists expected the spacecraft's instruments to slowly fade into silence, providing their final readings before the immense gulf of space swallowed them. Instead, Voyager 1 has sent back something completely unexpected, a discovery so puzzling that even seasoned astrophysicists have struggled to interpret it. At the very edge of the solar system, where the sun's magnetic field and charged particles thin into the blackness between the stars, Voyager 1 has encountered a phenomenon that seems to defy the laws of physics as we currently understand them. Before we start, smash the like and subscribe buttons for more updates. The spacecraft had already crossed into interstellar space years ago, yet its sensors continue to detect fluctuations in plasma density and magnetic fields that should not exist so far beyond the heliopause, the invisible boundary where the solar wind can no longer push against the surrounding galactic medium. The data suggested a region of space filled with waves of charged particles that seem to pulse and resonate, almost like cosmic echoes trapped at the boundary. This was unexpected because the interstellar medium was thought to be relatively calm, shaped only by the distant influence of supernova shockwaves and faint galactic currents. Instead, Voyager 1 revealed turbulence, structured and repeating in ways that no previous models had predicted. What makes this discovery even more astonishing is the persistence of these signals. As Voyager 1 drifted deeper into interstellar space, scientists expected the waves to fade and the plasma readings to stabilize. But the spacecraft instead recorded an environment that seemed alive with activity, almost as if the boundary region between the solar system and the galaxy was a dynamic, vibrating membrane rather than a clean dividing line. The heliopause, once thought to be a one-time crossing point, suddenly appeared to be far more complicated. A shifting frontier where the influence of the sun interacts with galactic forces in ways that remain mysterious. One implication of this discovery is that the solar system may not be as neatly contained as once imagined. The protective bubble formed by the solar wind, often described as a cosmic shield against galactic radiation, may actually be porous, leaking and shifting with the movements of plasma waves and magnetic structures. This challenges long-held assumptions about how effectively our star shelters the planets from high-energy cosmic rays. If these waves act like channels or conduits, they could allow radiation to seep in more freely than expected, altering the delicate balance that has shaped Earth's environment for billions of years. It forces scientists to reconsider the sun's role not just as a source of light and heat, but as a guardian against the galaxy beyond. Voyager 1's instruments, though aging, remain precise enough to measure these subtle variations in plasma density. The spacecraft detected a continuous low-frequency hum in interstellar space, almost like a background note resonating throughout the cosmos. This hum, steady and unrelenting, hints at a persistent energy field pervading the boundary region. It may be the faint whisper of interstellar gas vibrating under the influence of distant stellar explosions, or it could be evidence of an interaction that no one anticipated, something fundamental about how matter behaves in the vacuum between stars. Whatever its origin, the discovery proves that interstellar space is not a silent void but a place of hidden structure and resonance. The impossible part of Voyager 1's finding lies in how these plasma oscillations seem organized rather than random. In physics, order often implies a governing mechanism. But what could generate such persistent patterned waves at the very edge of our sun's influence? Some theories suggest they may be linked to galactic magnetic fields, weaving through space like invisible currents. Others propose that shock waves from long-dead supernovae continue to ripple across the galaxy, intersecting with the solar system's boundary and leaving imprints detectable even now. Yet none of these explanations fully account for the coherence and intensity of the signals Voyager 1 has recorded. It is as though the edge of the solar system is not merely a boundary but a resonant zone, capable of amplifying cosmic processes into forms we are only beginning to glimpse. This discovery forces a reevaluation of cosmic boundaries themselves. For centuries, human beings imagined the solar system as a kind of self-contained island in the galaxy, its planets and moons held securely within the sun's grasp. Now it appears that this grasp is less certain, more like a trembling hand reaching out into a storm of forces beyond comprehension. The heliopause is not a wall but a frontier, an active region of exchange where particles, radiation, and magnetic fields intertwine. Such complexity raises new questions about how stars interact with their galactic environment. If every star has its own protective bubble, then these bubbles may not be isolated but constantly colliding and merging in ways that shape the larger structure of the galaxy itself. Voyager 1's discovery also highlights the resilience of the spacecraft itself. Decades beyond its expected lifespan, it continues to act as humanity's distant sentinel, transmitting data from more than 14 billion miles away. Its instruments, designed in the 1970s, were never meant to reveal the detailed physics of interstellar space, yet they have uncovered a phenomenon that challenges even the most advanced theories. This paradox underscores how exploration often leads to revelations through tools and methods not originally intended for such purposes. Voyager 1's persistence has proven that curiosity, combined with engineering foresight, can extend human knowledge into realms no one imagined possible. The implications for astrophysics are profound. If Voyager 1 has indeed uncovered a structured resonance at the edge of the solar system, then our models of space weather, cosmic radiation, and galactic interaction must all be re-examined. For future missions, such as probes designed to leave the solar system intentionally, this means preparing for an environment far more dynamic and complex than once believed. What we thought would be a silent crossing into interstellar space may in fact be a journey through a turbulent sea of invisible waves. This could affect spacecraft design, communications technology, and even long-term plans for interstellar travel. After all, if space itself vibrates with hidden currents, then navigating those currents becomes as essential as charting the winds and tides of Earth's oceans. Beyond the scientific implications, there is something deeply human in this discovery. For thousands of years, humanity has looked at the night sky and wondered about the boundary between our world and the infinite. Voyager 1 has now crossed that threshold and revealed that the boundary itself is alive, shifting, and enigmatic. It is as if the universe refuses to be neatly categorized, insisting instead that every frontier opens onto another mystery. The spacecraft has not just sent back numbers and graphs, it has reignited the sense of wonder that drives exploration itself. The edge of the solar system is not a silent void, but a realm of cosmic music, a resonance that speaks to the vast, interconnected forces shaping the galaxy. What makes this moment extraordinary is how unexpected it was. Scientists had anticipated Voyager 1's crossing into interstellar space, but they did not foresee the spacecraft uncovering a kind of hidden order at the edge. It is a reminder that the universe often resists prediction, that discovery remains possible even in regions thought to be well understood. Voyager 1 has taught us that exploration is not just about distance, but about depth, about looking closely enough to see the subtle patterns that reveal a greater truth. The impossible discovery at the edge of the solar system is less a final answer than an invitation to keep asking questions, to keep reaching into the unknown. At the core of this finding is a profound lesson about cosmic humility. Humanity has achieved remarkable technological feats, sending spacecraft across billions of miles, yet even so, the universe presents us with mysteries that defy explanation. Voyager 1 has shown that the boundary between the known and the unknown is not fixed but always shifting, always revealing new layers of complexity. It reminds us that the universe is not static but dynamic, a place where discovery is not the exception but the rule. The spacecraft's detection of resonant plasma waves and magnetic anomalies is a signal that we are only beginning to understand the cosmic environment that surrounds us. For the future, this opens new avenues of exploration. Missions now being conceived may be designed with the specific goal of probing the interstellar boundary in greater detail. Instruments far more advanced than Voyager's could measure the structure and dynamics of these plasma waves, revealing whether they are local phenomena tied to our sun, or universal processes shaping the galaxy as a whole. Such missions would build directly on Voyager 1's legacy, transforming an impossible discovery into a foundation for deeper knowledge. But for now, the message is clear. The edge of the solar system is not a simple line, but a realm of mystery, where the cosmos itself seems to hum with energy and possibility. The story of Voyager 1's impossible discovery is not just about science. It is about the enduring spirit of exploration, the willingness to send a fragile machine into the unknown and trust it to reveal something profound. Against all odds, the spacecraft continues to speak across the void, carrying whispers of a cosmic truth that no one expected to hear. The universe has revealed one of its secrets, not through grand observatories or massive instruments, but through a tiny probe launched in an era when space travel was still new. This juxtaposition of simplicity and profundity is what makes the discovery so powerful. It proves that exploration is never finished, that even at the edge of the solar system, the universe still has surprises waiting. The Voyager 1 spacecraft continues to drift further from the sun than any object humanity has ever launched, and yet its discoveries have only grown stranger as the distance increases. What seemed to be a mission bound to fade into silence has instead revealed an entirely new domain of cosmic phenomena, a reality that stretches our imagination and demands new science. The impossible discovery it has made at the edge of the solar system, that curious and unpredicted turbulence humming through interstellar plasma, is only the surface of something much larger. To understand it, we must widen our perspective far beyond the technical details and look at the deeper implications this holds for the solar system, for interstellar space, and for our long-term vision of exploration. The plasma resonance that Voyager 1 detected speaks to a hidden complexity of interstellar space. This region was long assumed to be diffuse and uneventful, populated only by thin clouds of hydrogen, helium, and the faint whispers of cosmic rays. Yet the spacecraft's sensors revealed an environment more structured than anyone imagined. Plasma, being a charged state of matter, is guided by magnetic fields, and what Voyager encountered suggests that galactic magnetic fields are not passive background forces, but active participants in shaping cosmic space. It is possible that the magnetic environment surrounding the solar system forms corridors or channels, much like ocean currents on Earth, which funnel plasma in ways that create wave-like patterns. If this is true, then every star may be wrapped in a dynamic sheath of turbulence, each one interacting with its galactic neighborhood in a dance of unseen energies. This understanding transforms how scientists think about stellar systems in general. Previously, the focus was on planets, moons, and debris orbiting stars, while the boundary regions were seen as mere dividing lines. Now, these boundaries may emerge as key players in astrophysics, places where information about both the star inside and the galaxy outside is exchanged. A spacecraft passing through such a region becomes a witness not only to the story of its home star, but also to the collective forces of the Milky Way. Voyager 1, by recording this hum and turbulence, has stumbled into the role of interstellar anthropologist, gathering evidence of the cultural exchange between solar systems and the galactic environment. The scientific implications extend into the origins of life itself. Cosmic radiation, shaped by these boundaries, has profound effects on planetary atmospheres. Too much high-energy radiation can strip atmospheres or damage complex molecules, while too little may hinder the kind of mutations that drive evolution. Earth has enjoyed a relatively stable protective shield due to the heliosphere, but Voyager 1's findings suggest that the shield may fluctuate in ways previously unconsidered. If the heliosphere is porous, then over geological timescales, Earth may have been exposed to varying levels of galactic radiation. This means that the evolution of life could have been influenced not only by local factors such as volcanic eruptions or asteroid impacts, but also by the ever-shifting conditions of the solar system's boundary with interstellar space. Expanding this perspective, one might consider the search for habitable planets around other stars. If heliospheres are porous or resonant in the same way, then the habitability of planets may depend not only on their distance from their star, but also on the nature of their star's boundary interactions with the galaxy. Some systems might be flooded with radiation due to weak heliospheric shielding, while others may exist in calmer zones of galactic space. Voyager 1's discovery is thus not just about our solar system, it reshapes the criteria by which we evaluate the potential for life across the cosmos. What was once seen as an irrelevant detail, the turbulence of a star's outermost plasma environment, may in fact be critical in determining whether complex ecosystems can thrive. The technological story of Voyager 1 also deepens the intrigue. Built in the 1970s, its instruments were never designed with interstellar turbulence in mind. The plasma wave instrument, for example, was intended to measure the density and motion of particles carried by the solar wind. Yet as the spacecraft crossed into interstellar space, this same tool became the key to uncovering plasma oscillations beyond the heliopause. There is something poetic in this. An instrument meant for one purpose, outliving its expectations and finding a second life as a recorder of cosmic mysteries. It highlights the principle that exploration always carries with it the potential for unintended discovery. Future spacecraft will likely be designed explicitly to probe interstellar boundaries, equipped with instruments able to capture the nuances Voyager can only hint at. But Voyager remains the pathfinder, the pioneer, whose simplicity and persistence cracked open a door no one knew existed. The discovery also challenges the traditional mental image of interstellar space as silent. For centuries, poets and scientists alike referred to the cosmos as a void, a cold emptiness where silence reigns. Voyager 1 has shown that this is not true. The universe is not mute but alive with vibration, carrying faint notes that resonate across billions of miles. This revelation redefines the cosmic narrative. Space is not absence but presence, a medium filled with unseen harmonies. The spacecraft has, in a sense, revealed the music of the galaxy. Though inaudible to human ears, these plasma waves can be converted into sound, producing eerie tones that capture the imagination. It is a reminder that the universe speaks, if only we have the tools to listen. From a more speculative angle, the persistence of coherent plasma oscillations raises questions about long-range cosmic structures. Could these resonances connect distant regions of space, forming vast networks of energy transfer? Plasma physics already suggests that filaments and currents stretch across the cosmos, binding galaxies and stars into a web. Voyager's data may be evidence that even at the smallest scales of stellar systems, this cosmic web remains active. If true, then our solar system is not isolated but plugged into a larger galactic circuit. The implications here are staggering, for it means that energy, particles, and perhaps even information are constantly exchanged across unimaginable distances. The discovery blurs the boundary between local and universal, suggesting that our star participates in the life of the galaxy more intimately than we thought. On a practical level, this knowledge may become vital for future interstellar exploration. If spacecraft must travel through resonant plasma fields and magnetic turbulence, then propulsion systems, navigation strategies, and shielding designs must all take these conditions into account. Just as early sailors needed to learn the patterns of winds and currents to cross oceans, future explorers will need to understand the invisible seas of interstellar plasma. Voyager 1 has provided the first chart of these seas, crude though it may be, and its findings may one day guide ships far more advanced than itself. The impossible discovery is not just a curiosity, it may be the first lesson in the new discipline of interstellar navigation. Another dimension of significance lies in the psychological and cultural impact of the discovery. Humanity has always sought boundaries. From the edge of the known world in ancient maps to the limits of the solar system, each boundary crossed has reshaped our self-understanding. When Voyager 1 revealed that the solar system's edge is not static but dynamic, it forced a new reckoning. There is no final wall separating us from the galaxy. Instead, there is an ongoing conversation, a blending zone where inside and outside lose their meaning. This realization resonates beyond science, touching philosophy and culture. It suggests that separation is an illusion, that even in the vastness of space, everything is connected through invisible currents. For a species that often struggles with divisions and boundaries on its own planet, the message from Voyager carries a humbling truth. The discovery also stirs thoughts about time. Voyager 1 travels outward at tens of thousands of miles per hour, yet it will take tens of thousands of years to pass through even a fraction of the interstellar medium. The plasma oscillations it detects may themselves be the echoes of events that happened millions of years ago, supernova whose shockwaves still ripple through the galaxy. In this sense, the spacecraft is not just measuring space, but also time, receiving whispers from the deep past. The galaxy carries its history within its plasma, and Voyager 1 is the first instrument to listen. This temporal dimension reminds us that the universe is layered with memory, that every star and system carries the scars of ancient events. The discovery makes the edge of the solar system not only a frontier of space, but also a window into time. Perhaps the most profound implication is the realization that the universe resists simplicity. Human beings crave clean boundaries and clear categories, but Voyager 1 has shown that the cosmos does not operate in such terms. The solar system's edge is neither inside nor outside, neither silent nor chaotic, but something in between, a zone of interaction, resonance, and flux. To confront this truth is to embrace complexity, to accept that the universe is not a static stage but a living process. This discovery challenges not only scientific models, but also our imagination, forcing us to expand our understanding of what it means to explore. Exploration is not the crossing of a line, but the engagement with a process that never ends. Even as Voyager 1 drifts further, the importance of its discovery grows. Every additional mile it travels deepens the mystery, as the plasma oscillations continue to hum and shift. The spacecraft is not moving into emptiness, but into richness, into a domain filled with forces beyond our comprehension. Each transmission is a reminder that the universe remains full of surprise. What once seemed impossible, a spacecraft measuring coherent plasma resonance billions of miles from Earth, has now become reality. And with it comes a new horizon of questions, each one as vast as the space into which Voyager sails. This is what makes the discovery impossible and yet undeniable. It defies our previous understanding, upends our models, and stretches our imagination. Yet the data are real, the hum is measurable, and the implications are profound. Voyager 1 has revealed that the edge of the solar system is not a boundary but a frontier, a living threshold where the forces of the sun and galaxy meet. In doing so, it has given humanity a new vision of its place in the cosmos, not isolated, not silent, but resonant, connected, and forever part of the greater galactic whole. Voyager 1's strange and unprecedented findings at the edge of the solar system are not only reshaping astrophysics, but also influencing how humanity conceives of the cosmos as an interconnected whole. The hum of interstellar plasma waves, the unexpected turbulence, and the unanticipated activity at the heliopause are, in many ways, a challenge to everything scientists thought they knew about the final boundary of the sun's domain. To add to this, the deeper implications stretch into disciplines as varied as planetary protection, cosmic cartography, theoretical physics, and even metaphysics. There remains a vast amount to be said about what this discovery means, not only for the present, but also for the far future. One of the most intriguing aspects of Voyager 1's detection of structured plasma resonances is the suggestion that the galaxy itself may contain hidden communication channels of energy. Plasma physics has long shown that charged particles can self-organize into filaments, spirals, and waves that persist across great distances. In laboratory experiments, plasmas often exhibit behavior that seems far too complex for the amount of energy input. Scaling this up, Voyager's discovery suggests that the edge of the solar system may be part of a far-reaching galactic architecture. In such a vision, stars are not isolated entities, but nodes in a cosmic web linked by plasma currents. This implies that Voyager has, in its own way, touched the fabric of galactic structure itself, confirming that the galaxy is not only gravitationally bound, but also electrically connected. If these plasma channels carry energy in structured ways, then they may also play a role in the transfer of matter between systems. Interstellar dust and ions could be funneled through invisible corridors, altering the chemical makeup of local environments. For the solar system, this could mean that rare isotopes, exotic dust grains, and energetic particles continually flow inward from the galactic medium. Over billions of years, such flows could subtly alter planetary atmospheres or contribute to the building blocks of life. Voyager's discovery opens the door to the possibility that interstellar chemistry is not simply random, but shaped by organized flows and resonances. Life on Earth in this scenario is not only a product of the Sun and Earth's unique conditions, but also of galactic interactions spanning light years. Another unexplored implication lies in how Voyager 1's findings may inform the search for extraterrestrial intelligence. For decades, efforts to listen for alien civilizations have focused on detecting radio signals. But what if advanced civilizations have long since learned to use plasma resonances as a natural medium for communication? Unlike radio waves, which disperse quickly, plasma oscillations can propagate through galactic magnetic structures and persist for extraordinary distances. Voyager's hum could be purely natural, yet it raises the question, might plasma itself be a galactic-scale medium that intelligent beings could harness? If so, the spacecraft's instruments may have stumbled upon a fundamental infrastructure of communication that humanity has only just begun to recognize. This possibility expands the scope of SETI, suggesting that listening for resonance patterns in plasma might be as important as scanning radio frequencies. The impossible discovery also forces us to reconsider the fate of future interstellar travelers, whether robotic or human. Spacecraft crossing into interstellar space will not be entering a dead vacuum, but a region humming with energy. This could be both a challenge and an opportunity. On one hand, the turbulence may endanger delicate instruments, disrupt navigation, or create noise in communications. On the other hand, structured plasma waves could serve as a potential source of energy. Just as wind and tides provide renewable energy on Earth, plasma oscillations might be harvested by advanced spacecraft to sustain long-duration journeys. Voyager 1 has not only revealed the existence of these resonances, but also hinted at an entirely new resource waiting to be tapped by future explorers. When considering the cosmic scale of this discovery, one must reflect on how it reshapes the concept of borders. Humanity has long drawn lines to separate domains. The horizon, the edge of a continent, the boundary of the atmosphere, the orbit of the moon. Yet each time these lines are crossed, they dissolve into gradients rather than barriers. The edge of the solar system is proving to be no exception. Voyager 1 shows that there is no clean break between our sun and the rest of the galaxy. Instead, there exists a liminal zone, a threshold, filled with interaction and ambiguity. This resonates with philosophical perspectives that view boundaries not as fixed, but as living, shifting, and porous. It calls for a new mindset in exploration, one that accepts that crossing a boundary does not mean leaving one world behind, but entering a dynamic continuum where everything overlaps. In terms of cosmic cartography, Voyager's discovery implies that maps of the galaxy will need to include not just stars and planets, but also resonant zones, turbulence fields, and plasma structures. Just as ancient mariners charted not only coastlines but also currents and prevailing winds, so too will interstellar maps include regions of turbulence and calm. The heliopause may be redefined not as a fixed line, but as a region of layered boundaries, each with its own properties. Some layers may act as shields, others as channels, and still others as amplifiers of galactic forces. Voyager has revealed the first hints of this cosmic topography, and one can imagine a future where explorers rely on detailed charts of plasma resonances the way sailors once relied on star charts. From the perspective of theoretical physics, Voyager 1's detection of coherent plasma oscillations raises profound questions about energy distribution in the universe. Plasma is highly sensitive to magnetic fields, and the ordered patterns suggest that galactic magnetic fields are more structured than previously assumed. This intersects with questions about dark matter and dark energy. If magnetic structures influence plasma on interstellar scales, could some of the effects attributed to dark matter, such as unexplained gravitational behaviors in galaxies, actually be partially explained by plasma dynamics? While speculative, Voyager's discovery adds a tangible piece of data to this debate, showing that plasma behavior in interstellar space is far from trivial. It opens the door to models where the visible and invisible universe interact in ways we have not yet accounted for. There is also a humanistic dimension to all of this. Voyager 1 carries with it the Golden Record, a time capsule of humanity's sounds, images, and greetings. The spacecraft is both a scientific probe and a cultural ambassador. The fact that it has now encountered a cosmic hum resonates symbolically with its mission. It was sent out to represent humanity to the stars, and in turn, it has discovered that the stars themselves sing in plasma waves. The Golden Record may one day be encountered by another civilization, but even if it never is, Voyager has revealed that the universe itself already contains a universal language, resonance. This alignment between the spacecraft's symbolic mission and its scientific discovery is poetic in a way that transcends data and charts. Another underexplored implication is the way this discovery will influence how we think about interstellar hazards. Radiation has always been considered the primary danger to long-distance space travel, but turbulence at the heliopause suggests that interstellar weather may be as complex as terrestrial weather. If so, then spacecraft may need to forecast and respond to plasma storms, turbulence fronts, and magnetic surges. The heliopause may be like the Earth's atmosphere, predictable in some ways, chaotic in others. Voyager has given us the first glimpse of this environment, but it is clear that much remains to be learned. Future missions may need to carry instruments specifically designed to monitor and adapt to interstellar weather conditions, making this discovery a catalyst for new kinds of spacecraft engineering. The hum detected by Voyager 1 also has implications for the origin and destiny of stars. If plasma oscillations are widespread, they could play a role in how matter collapses to form stars and how energy disperses when stars die. It may be that these resonances act like pressure valves, distributing energy across the galaxy in ways that stabilize the cosmic environment. Without them, galaxies might be far more violent, with shockwaves tearing apart fragile star-forming regions. Voyager's small data set hints at a galactic process that may be as fundamental as gravity or fusion, a balancing mechanism that maintains the delicate interplay of chaos and order across the stars. The unexpected discovery also invites reflection on how humanity perceives the unknown. For centuries, the word void has been used to describe the space between stars, but now that word seems inadequate. Space is not void, it is dynamic, vibrant, filled with hidden energy. This realization alters the emotional relationship humans have with the cosmos. The interstellar medium is not empty coldness, but a kind of invisible ocean, alive with currents and harmonies. For explorers, this is a source of wonder, but for poets, philosophers, and dreamers, it is a revelation. The universe is not silent. It has always been singing, and Voyager has simply given us the means to hear it. If you like this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us. What are your thoughts on Voyager 1's new discovery at the solar system's edge? We want to hear from you. Thank you for watching, and see you next time.